The last couple of videos we've been looking at derivatives and of trigonometric functions, and hopefully you've had an opportunity to have a look at the notes and so forth regarding antiderivatives or integrals of inverse trigonometric functions. And what I'd like to do in this short video is to do a few examples of applying those antiderivatives. So you can see on the screen there that we've got the antiderivatives relationships in front of us. Remember, for specialist maths, you don't actually have to remember those relationships. They are contained within our formula book. You can see them there. So don't panic. Don't think, oh, I'm never going to remember that. That's all good. You don't need to. It's going to be there right in front of you anytime you need it. So if you aren't in the habit of getting your formula book out and having it on your desk beside you whenever you're working in this area, please do so. Okay, so we're going to be looking at the antiderivatives in this particular set of examples. So I've got a couple of examples here, and I've got a slightly more difficult one towards the bottom. So we'll do the one on the left-hand side first. So we're doing the integral this time. Integral of 12 over the square root of 36 minus x squared. So what we need to do first of all is identify, well, first of all you need to recognise that it's in the form that the integral is going to be one of our inverse trig functions. And hopefully very quickly you will notice that first of all we've got it's positive, all right, and we've got a term minus x squared. So if we look at our inverse trig functions, that's quite clearly a sine function, or has the potential to be the inverse sine function. So we're going to use the concept that the integral of 1 over the square root of a squared minus x squared dx is equal to the inverse sine function of x minus a plus c, pardon me, for values between negative a and a. Okay, so we need to say, all right then, well, there's a couple of things different. What are the things that are different? Well, let's deal with the denominator first. So we've actually got 36, so first thing we're going to do is put it in a squared. So we're going to rewrite the function, so actually I'll ignore the 12 just for a minute, I'm going to come back to that. Let's just worry about the denominator. So instead of writing a squared, or 36, we're going to write it as 6 squared minus x squared. Okay, so that hopefully will identify very quickly that that's our a value. So that's all good. So we've got our a value. What do we want on the numerator? We want 1. What have we got? 12. So the beauty about integrals is that we can just multiply. We can take the factor of 12 out the front. So that makes things very simple. So that we can just multiply that out. So we now have it in the form that we want it in. So that'll just now become, that'll become 12. The integral of that is going to be sine to the minus 1 x over, and what is a? 6 plus c. And there's our solution. Second example, this time we're finding the antiderivative of the function c, 4 over 16 plus 9x squared. All right, so pretty much the same idea, except this time, as you can see, we've got plus. All right, so first of all, that eliminates the first two, and it's a squared plus x squared, so it's probably going to be, and there's no square root sign, so it's probably going to be a tan function. So let's see, so if we want to find the integral of that, okay, dx is what we're actually trying to find. So it's going to be, we're going to use the idea that the integral of a over a squared plus x squared dx is going to be the reciprocal function tan minus 1 x on a plus c. And we've got our domain we already realise is the real values, the real numbers I should say. So now we've got to try and work out how we're going to put the function we've got into the form that we want. First of all, what you need to notice is the coefficient of x squared is 1. So the second thing, we're going to take the 4 out. We're just going to move it away. Oh, yeah, we'll move it away for the moment, just to get it out of the way. We may need to put it back later, but we'll wait and see. So first of all, let's move it away. The second thing we're going to do is make the coefficient of x squared 1. So how are we going to do that? Well, there's a couple of things we can do, but what we're going to do first of all is, well, if I divide the 9x squared by 9, then I can divide the 16 by 9 as well. Okay, so I'm going to make that 16 over 9. So if I've taken that by doing that, then effectively what I've done is I've factorised. So I've taken out a common factor of 9. So let's leave that like that. Okay, so I can now take that out the front as well. And I've got 1 over, and if I write that in the form 4/3 squared plus x squared, we're now getting closer and closer to the function that I actually want. Now, it's not quite exactly the same as what we had before where we wanted a 1 in the numerator. This time we actually want 4/3 in the numerator because that is my a value. So if I'm going to introduce 4/3 into my numerator, then I can't just introduce it because it changes the balance of the problem. So I can also, if I then multiply by 3/4 out here, I can multiply by 3/4 inside and then move it out anyway, then I haven't changed the balance of the problem, but it's now in the form that I actually want. And so what I've got now is 4/3 over 4/3 squared plus x squared, which is my form that I want. So I've got to have 4 times 3 is 12, well the 4's cancel, I've got 3 over 9, which is 1/3, 10 minus 1, x on 4/3. Let's see, and that looks pretty ugly, so let's just rewrite that. So 1/3, 10 minus 1, 3x on 4 plus c. And there's a solution to that problem. Now, there is an easier way of doing that without all these 4/3 and so forth. And when we learned that, it's called bilinear substitution, and we'll learn that process in a week or so's time. But for the moment, we can see that the process works for this example. Our third and final example is very similar to the one we just did. So what I'd like to do is I'm going to pause the video in a moment, and I'd like you to have a go at it. Okay, so look at it, look at the type of function it probably is going to look like, and then see if you can manipulate the problem so that you can get it into the form that you need. All right, so I'm going to pause the video, have a go, and then when you think you've either got the answer or you just get completely stuck, then start the video again and you'll see the work solution. Okay, so you've either got the solution out and you're very pleased with yourself and you want to know if you're right, or you've got stuck. So either way, let's work our way through it and see if we can come up with a solution together. All right, so first things first, we need to identify, is it an inverse trig function that we're going to get as our solution? Well, obviously it is, A, because we're in that topic, but B, if we look back, it's similar to the question we did a bit earlier, where we've got a minus x squared, it's a positive A at the top, so it's going to be the sine function. So again, we'll write down the integral that we're actually trying to get towards. Okay, so now again, we've got to try and get into that form. So this one's not quite as nice and neat. And once again, when we learn another integration method shortly, we will find this a lot easier to do. But anyway, let's just work it through and let's practice our fraction work. I know we all love fractions. So first things first, we need to get the 4 out of the way. So we'll do that first of all. So we've got the integral 4 on square root. Let's write it in terms that we are comfortable with. So we're going to, oh no, we'll do it this way first. So 49 minus 36 x squared dx, that's going to be equal to 4 outside of, okay, so we've got the 1 on the top. Yay, that makes things easy. So now we're going to play around with this 49 minus 36x squared. So let's just do that over here. So just roll a line off. So square root 49 minus 36x squared. Okay, we want that to look like the square root of a squared minus x squared. That's what we want it to look like. So you'll notice again we've got the 36 in the way. So we're going to take out a common factor of 36. So we're going to come over here, take the square root. So the common factor of 36 out the front, leaving me with 49 over 36 minus x squared. Okay, well, that's all square rooted. Okay, so fortunately, we know our surd rules, and we can split up our two surds into two separate terms. We know the square root of 36 is 6, and then we can do the square root of, so this is going to be, sorry, not the square root, this is going to be 7 on 6 squared minus x squared. And we can see that our a value is 7 on 6. So we come back over here now, and we say, right, well, we've already simplified that using our working over yonder. So we've got 7 on 6 squared minus x squared. Whoops, that was straight, wasn't it? So now we're going to take out our 6. I'll simplify that shortly. 1 over square root of 7 on 6 squared minus x squared. Shoot. Dx. Oh, I've got the dx there too. Sorry about that. Okay. And so 4 over 6 is 2/3. We are now in the form that we want. Okay, so this is going to be sine minus 1 x over a, well, a is 7/6. Let's see. And so just to tidy that up, to make it look a little bit more neater, 2/3 sine minus 1, 6x over 7 plus c. And we found our antiderivative.